Well, so I can start. So first, hi, my name is Angel, as you can see there, and I'm going to present you my work or our work on leveraging Zarr for handling RDF data. I'm not the only one who contributed to this, but also Diego, Jose Emilio Labragallo, and Josh Moore. So without further saying, let's get started. What have we done? So first, these are the two main approaches that you could follow when it comes to working with large RDF datasets. You could decide to load your RDF dataset, your dump, on a local repository, but if it exceeds the resources of your machine or your desktop, you will come to an issue. So yeah, you cannot perform any query or anything like that. Another alternative could be following this client-server architecture, highly used. You could have an Sparkle endpoint or whatever, and move the dataset to the server, but with the cost of having a single point of failure, which could be the endpoint, where different clients will try to connect to it. And well, the clients will have reduced their usage, but the endpoint will be fully loaded. Imagine complex Sparkle queries to it. You could have and bottleneck there. So what have we tried to follow is this serverless architecture and trying to combine the best of both worlds. So you will move the dataset to the server, but trying to preserve as much load on the client if possible. So the idea is to have the dataset there. I will explain you how, and through a series of functions, we call it API. You have this serverless architecture where the clients connect to there, and just by a function they can retrieve what they need. So how do we do that? Really easily using Zarr. Zarr is a distributed multidimensional array storage format. What that means is that you basically have a remote connection to a dataset, to a store, which is in the shape of a multidimensional array. And why that's interesting? Well, those four elements in bold, those are the most important. Distributed, we need that. We want to have it on a server, so perfect. Array, we will see why that's important. And the storage format, obviously, we are going to make a triple store, so we need something to store stuff. So it's also important to note that Zarr is built on top of two main abstractions that I'm highlighting even more, but those are the most important ones for me. Chunking, which is dividing the array into pieces, really simple, and compression, which it's just an algorithm that tries to optimize the storage as much as possible. We have made those equivalences. I don't like that symbol. In this case, it's just the relationship that we find with RDF. So chunking aligns with the concept of graph neighborhood. One of the most basic operations that you can perform, obtaining the neighborhood of a subject and stuff like that. Simple operation, nice for a triple stop to have. And compression, which aligns with the concept of prefixes. At the end, prefixes are, like a kind of compression. You repeated terms can be compressed in that sense. So we are going to use those two abstractions to take advantage of them, and you will see what are the benefits. So basically, chunking allows us to have parallel access to the datasets, which is fine. We will see at the end why for querying, and the distributed and serverless architecture is also fine because it allows us to combine that hybrid approach and the optimized store thanks to compression, thanks to what I've mentioned earlier. So we have those advantages, those benefits, and we will try to exploit them as much as possible using Zarr. So what we have here, just to summarize, we have a columnar storage, and this is important because from my view, RDF is columnar oriented. You have a series of rows, but just three columns, the subject, the predicate, and the object. So with that, we are going to try to replicate it in a matrix array and in an array which is not so columnar. It's, you have 2 dimensions. We only want one, which are the rows, but it's enough. And so the idea is to have 1 row per triple and 2 columns. You will see why 2 columns just now. The idea is that we'll have 3 indices replicated, 1 for the subject, 1 for the predicate, and 1 for the object, 1 per component. And the idea it is that the elements there will be grouped by the corresponding component. So for example, in the case of the subject index, we will have everything grouped by the subject. Easy. And the idea is also that we will try to compress the terms inside of there. We are not going to store them as CVs. We are not going to store them as complex structures. We are going to store them as integers, which are fantastic because Zarr allows us to do so. And using the front coding algorithm, you know it from HTT possibly, we are going to take advantage of what I mentioned about prefixes, about compression, and all that stuff. So also thanks to from coding, we are going to store everything in a lexicographical order, which basically means by the alphabetical kind of order. So let us see this example here. We have, as you can see, 3 subjects and 6 objects and a series of predicates, a simple graph, and we are going to see how we can represent this exact graph using our store. So the idea is that we will have 3 indices. The first one is the subject index, and the idea is that we will to store all the triples by subject. So you can see 3 chunks, one for the first subject, which is A, chunk 2 for the B subject, and chunk 3 for the third subject. So really simple to have it. Note that in the end, in Zarr, we are not going to store them as you can see there. We are going to store that as integers, but for the sake of clarity, we are going to see the examples using human readable terms. And we have also the predicate index, which is mostly the same. You can see 3 chunks also for each predicate. The last one is the name predicate. You see a lot of triples there. And you have also the object index, which is exactly the same, but using the objects. So chunks corresponds to objects, and then you have the subjects and the predicates. And so with that said, we are going to see how do we query this. So we are going to see this simple triple pattern where we are going to retrieve all the triples having the A subjects. So we are going to go to the subject index, which is the one that is preferred for subject operations, and we are going to retrieve all the triples whose subject is A. Really simple to do. So note that this process in Zarr is trivial. As we said earlier, chunking aligns with the concept of graph neighborhood. So this is fantastic because this is the most operation in Zarr, which is the most simple one, just retrieve one chunk. And so that's how we do this simple operation. We can do even more operations. For example, this one here, retrieve all the triples whose subject is A, whose predicate is name, and we will do exactly the same. It's a subject-oriented operation, so we will retrieve the first chunk, which is the first subject, and retrieve all the triples whose predicate is name, so we will retrieve the first triple there. So we are going to do some kind of tricks, which is basically this second operation, which is a bit more complex, could be more complex. We're going to do that on the client. So that's what we are going to try to aim for. Do the most simple operations just in the server, which is retrieving only chunks, and all the rest of operations, if you want to perform some modification or what you want to do, you are going to do that on the clients. So, well, something that I want to mention also, imagine that instead of doing triple patterns, you want to perform basic graph patterns. You could also do that by retrieving other chunks in parallel. So you are not conflicting with the first chunk. Imagine you want to perform an operation over the third chunk, you can do that. It is just retrieving that chunk and doing that in parallel, concurrently, or whatever you want to say. And so also for clarifying, this is not an Sparkle replacement. It's not a Sparkle engine. It's not fully capable Sparkle engine. You're going to perform joins or stuff like that. And it is not fully implemented yet. We are only implemented, or we have only implemented the triple patterns. So that's what I have not put an effort to explain the basic graph patterns because we are not there yet. But in the future survey, we are willing to create some benchmarks, to draft some benchmarks. The idea it is that we want to compare it to Parquet, to a Parquet-based triple store, to HTT, triple pattern fragments, and Sparkle endpoints. And the idea it is to use it in real-world scenarios, for example, for shackle validation, for checks validation, that we are also working on the research group. And also, as I said, implementing the basic graph patterns and try to have the full implemented things. So that's it. I said I was going to be fast. And yeah, you can contact me here or talk later. We can discuss it. And that's all.